you this. The possibility exists that we could have a day tomorrow. Okay? All right? They are expecting 4 to 7 inches of snow tonight into tomorrow with 40-mile-an-hour winds. Okay? I'm telling you that the possibility exists for a day. Because if that is the case, where we have a day tomorrow, okay, then Pi Day is virtual. Okay? Here's why. Okay? Here's why. Because we can't wait until Tuesday, because your pies will probably not taste as good. With me? And you can't wait until tomorrow morning to make your pie, because if we do or we don't, you know what I mean? You're going to have to make your pie if it's not already made. You're going to have to make your pie tonight. With me? So if we don't have school tomorrow, Pi Day is virtual, meaning make a video of your pie, okay? Promote the crap out of it in your video, okay? Make it be like a presentation, and then email that to me or Schmel, okay? And then that's how we'll judge your pies, okay? Understand? Now, if I will also tell you that the possibility exists for Monday being a snow day. Because Monday, they're talking somewhere between, and this is no lie, so Sunday, they're talking somewhere between a dusting and 2 feet of snow on Sunday. Okay? Okay? Depending on how the butterfly flaps its wings. Okay? Because right now, we're on the edge of a 10 to 20 band. Okay? Right now, we're predicted Sunday night into Monday morning to get 5 to 10 inches more of snow. Look out upon the green grass, because you might not see it for a while. Okay? All right? Exactly. Okay? So just so you know, so have those things in mind when you're going through. If we are gone tomorrow, obviously Pi Day is going to be via video, and you'll email it to us. Okay? If we are gone Monday, your formative is still Tuesday. Okay? We're not pushing anything back. We're sticking with the schedule. We would just adjust Pi Day, because that's the only thing we plan this month. Everybody understand the plan now? Okay? All right? Fantastic. Okay? So this is potentially canceled, but still right now a go. This is for sure. This is for sure. Okay? So test on formative on Tuesday, test the following Wednesday. And again, if we're looking forward to that one too, if you look back on the schedule in the back there, pre-ACT is that Tuesday. Okay? Now juniors and seniors don't have to come to school that day. I can't allow you to come to school because we need a quiet testing environment, and they're using like all 3 floors for that one, because it's not just juniors. Okay? But I would be available if you need extra help prior to the test on that Tuesday. I'm not proctoring because I did ACT, so I would be available to open up an office, a virtual office hours, and have a Google Meet going all day, and you just come in whenever you need help. If you want. You just got to email me, and I can do that. Okay? All right? Whew! All right, let's get into it. Oh, by the way, happy National Popcorn Day, too, today. Yeah. It is also Girl Scout Day, too. Okay? Yeah. So those of you that were in the Scout or the Girl Scouts, happy Girl Scout Day, too. Whoa! Hey, now, come on back to me. Come back to me in the right format. There we go. All right. All right, so here are your 2 complex numbers. I would like you to give me z sub 1 times z sub 2 in trig form and standard form, and z sub 1 divided by z sub 2 in trig form and standard form. Oh, this one's going to be good. I can already see it. I love it. So excited.
I already forgot what yesterday was the last straw. That's what it was.
So that's quadrant 4. Yep. So that's 360. Okay, so then that's going to be Ooh, I was trying to hold it in to get the 4 written. Ooh. Yamahama. Store that one as G. Hey, what?
Last week I went to the MRC to ask what went on
Yeah.
and they told me I couldn't do that and I had to go ask my teacher, but I asked you and you said I'd go there, and so then I didn't get a calculator, so then I just couldn't.
For which one? For vectors or for this?
No.
You could have used a regular calculator for that.
Yeah, I know, but it was taking me forever. So then I had to plug.
You had to write all that stuff down?
Yeah, and I was trying to do it in my calculator where I didn't round, so I like
Gotcha.
redid the problem when I had to bring back that number and I like messed it up. That means fridge.
Fridge.
So yeah. And then I didn't get a calculator. And my sister took hers. Why would she take her calculator? Because she's like, why would she take calculus as an engineering major? Why would you need math?
Lots of math.
I know, I'm being dramatic. I can't think of a reason, so. I can't. Dang it.
Alright, so z sub 1 times z sub 2 is going to be the square root of 34 times the square root of 117 cosine I sine of 300.964 degrees plus 326.310 degrees. That again. Okay. So then that's going to be the square root. Oops, that breaks here. The square root of 34 times the square root of 117 is going to be 63.071 cosine I sine of, so then this is going to be 627 degrees, but that's outside first lap. So that would be 267.274 degrees. In standard form, then that's going to be 63.071 cosine of, I'm just going to put theta to save space. So then this is going to be, I gotta get back up to this one. So that's going to be A cosine of Z. If you do it exact, I get -3. Minus 63 pi. Questions, comments, concerns, clarifications? Okay, then divide. So now z sub 1 divided by z sub 2 is going to be the square root of 34 divided by the square root of 117 cosine I sine of 300.964 degrees minus 326.310 degrees, which is going to be a negative angle, so we're going to have to add those angles together now. Okay, so first off, let's do the square root of 34 divided by the square root of 117. And let's store that. That was my A value. So this would be 0.53. Oops, step brakes. That's the wrong color. Oops, step brakes. It didn't even work. .539 cosine I sine of 334.654 degrees. Yes. Which would also be 0.487. Basing it off of a hunch here that it's going to be plus. Oh, nope, I lied. See, I shouldn't have. Minus 0.231. Always after. It's like a variable. The only time that it would ever come in the middle would be as if there's a radical. If there's a radical for that d value. Yep. Yep. Good?
It's like online. Yeah, it's online.
Okay. All right. So I want you to right now for me calculate negative or 2 minus 2i times the square root of 3 to the 5th power. What does it mean? What does that mean? It's like that times itself 5 times, right? So this is like 2 minus 2i square roots of 3, there's 1. 2 minus 2i square roots of 3, there's 2. 2 minus 2i square roots of 3, there's 3. 2 minus 2i square roots of 3, there's 4. 2 minus 2i square roots of 3, there's 5. 1, 2, 3, 4, 5. Yep. Now what?
I don't think that's
Is what? I don't think it's efficient either, but we still got to do it, right? Because that's going to be a number, right? Okay. So now we got to do this, right? Here and here. So that's going to be 4 minus 4i square roots of 3. Then here and here. That's going to be minus 4i square roots of 3 plus 4i squared times 3, which is really 12i squared, which is really minus 12. So this would become, really this is negative 8 minus 8i squared roots of 3. Right? Right? And these two would be the same thing. But then I still got this one. Right? And so now we got to do the process all over again. And then after that, we got to do the process all over again. Right? Okay? So let's think about this in terms of, this is a complex number. Let's think about this in terms of converting it to trig form first. Okay? Oh no, we were never going to do it. That's a lot of work. Okay? So, what's my R value? 14? Which one? Because this is 4 plus 12, right? So R is 4. 2 squared is 4. Square root of 3 squared is 3. 4 times 3 is 12. 2 squared is 4. 12 plus 4 is 16. Square root of 16 is 4. Yep. Okay. All right. Which quadrant is this complex number in? Fourth quadrant. So what's my theta value? 300 degrees. So this is really 4 cosine I sine of 300 degrees to the 5th power, right? Which means what? But what does it mean first? It's what? It's that times itself 5 times, right? So it's 4 cosine I sine 300 degrees times 4 cosine I sine times, or 300 degrees, and so on and so forth, like the last one, right? Okay. What do we do when we multiply complex numbers? Okay. So how many times am I going to multiply the R value? 4. I'm going to multiply. So this is really going to become 4 times 4 times 4 times 4 times 4, right? Cosine I sine of times plus, right? Oh, I can't make it. right? Okay, so what's 4 times 4 times 4 times 4 times 4? 1,024. What is 300 plus 300 plus 300 plus 300 plus 300? 1,500. Do I like 1,500 as an angle here? Okay, so what is it going to be then? 60? Okay, 1,500 minus 720 minus 720, 60. Yep. Okay, so this is 1,024 cosine I sine of 60 degrees, which cosine at 60 degrees is 1/2. Sine at 60 degrees is √3/2. I almost said 5,000, which would also be 512 plus 512 I square roots of 3. So if Zoe was like 3/4 of the way done with multiplying it all out, if you would have finished all the way through, you would have gotten 512 plus 512 I squared. So this is called de Moivre's theorem. Okay? De Moivre's theorem gives us a shortcut to finding powers of complex numbers. What de Moivre's theorem says is exactly what you just told me. You take, if you've got a complex number, so if we have a complex number here, actually I'm going blue because I put red up there. Z equals R cosine I sine of theta. Okay? If we take that complex number to some power, we take the R value and we take it to that power. We multiply all those R values however many times that we have. Okay? We did that. Okay? And then we take these two here, we take theta, and we multiply it by, now we added it. We went 300 plus 300 plus 300 plus 300, but we could have done 5 times 300. Okay? And you get that. Then, you will more than likely, more times than not, for sure, you're going to have to adjust that theta value back into first one. Okay? We had to subtract off 364 times when it was 1,500 to get on that first one. Okay? Much, much faster. Okay? Let's put it to use. So, we've got -3 plus 3i, and we want to take that to the 4th power. First thing that we're going to have to do, we're going to have to convert this into trig form. I get 3 square roots of 2. Then we're going to have to find our reference angle. So my reference angle is 45 degrees. Negative positive puts me in quadrant number 2. So my actual theta then would be 135 degrees. So my complex number in trig form would be 3 square roots of 2 cosine I sine of 135 degrees. And to that, I am going to take that to the fourth power. So that is going to then be 3 square roots of 2 to the fourth power cosine I sine of 4, of 4 times 135 degrees. 3 to the fourth power is 81. Square root of 2 to the fourth power is 4. 81 times 4 is 324. Square root of 2 times the square root of 2 is 2. Square root of 2 times the square root of 2 is 2. 2 times 2 is 4. 3 times 3 is 9. 3 times 3 is 9. 4 times 9 times 9 is 324. 4 times 135. 540. Don't like it. Subtract off because it's outside the first lap. So I got to subtract off, right? So 180. Okay. So then this would be cosine I sine of 180 degrees. Okay. There's my trig form. My standard form would be negative 324 plus 0i. Because it's 180 degrees, and 180 degrees is left on the unit circle. So I go out 324. With me? Ready to try one on your own? Let's do it. Go for it. I get an R value of 2. I got a theta value of 60 degrees. So this is 2 cosine I sine of 60 degrees taken to the fourth power. 2 to the fourth power is 16. Cosine I sine 4 times 60 is 240 degrees. This is one of those rare occasions where we don't have to do any adjustments whatsoever. So this would be 16 cosine of 240 degrees plus I sine 240 degrees. Cosine at 240 is negative 1/2. So this is going to be, whoops, got the brakes, come on now. This is going to be negative 8. Sine at 240 is negative root 3 over 2. So that's going to be minus 8i square root of 3. Questions on either one of those? If it's unit circle, exact. Yep. If it's not unit circle, rounded to 3. Yes, that would be wrong. Because 240 is on the unit circle. Yep. Yep. Okay. You now have enough in your toolbox to get through numbers 24. Okay? So you're 1 through 24 now on your homework.